This is our final section for the year. What we want to do now is start to develop a more elaborate protocol for evaluating limits, to develop some new techniques for evaluating limits without having to make tables, and to set up a structure of figuring out which techniques should I employ and in which order to some extent should I employ them. So we're going to start by just kind of listing out all the different possible techniques, and then I'm going to go through and give examples of each of the techniques so you can get some sense of how those techniques work, and you'll be able to practice all the different methods for finding limits here. So let's review a little bit of what we learned in the last section. From the last section, we know that when a function is continuous, we can find limits for that function using substitution, right? So since substitution is always going to be our easiest, our first instinct for finding a limit will always be direct substitution. I'm going to repeat this a number of times in the next few months. So let me start here. Our first instinct for finding a limit will be direct substitution. If you're asked to find a limit, the first instinct that you should think of, the first technique that you'll think of to employ, should be direct substitution. If I were asked to find a limit, the first thing that I would try to employ is direct substitution. Whenever we're asked to find a limit, the first thing that we should try to do is direct substitution. So our first instinct for finding a limit is direct substitution. Now I belabor that because what's going to happen here is, in the homework from the last section, you did a bunch of problems with direct substitution. You got super excited because now finding limits is super easy. But as I mentioned, as we go forward, we're really going to focus on limits at values where the function is not continuous. So we won't be able to do direct substitution for most of the limits that we are asked to evaluate. But that doesn't mean we shouldn't try direct substitution. We should always start by trying direct substitution, and when direct substitution doesn't work, then we're going to proceed through this here list of different techniques. So this is what this is saying here. So it's not that interesting for us to find limits if the function is continuous, right? It's fairly mundane to find limits at points of continuity since you're just substituting. So we'll focus most of our time where the function is not continuous and figure out how to find limits at those points. So we're still always going to start with direct substitution. Our first instinct for finding a limit will always be direct substitution. So that's always what we should try to do first. Always try direct substitution first. Then, if direct substitution doesn't work, we're going to work through this list of different possibilities here. Now, this year, in this course, in this section, we're really just going to go through this group right here under point 2. We'll get to these different ones here in the next school year. We've actually already done these two, so those are already done, check. And then this is what this section is going to be all about, is how we can use different algebraic techniques to find limits where we can't use substitution. So don't worry about 3, 4, 5, and 6 this year. We'll learn about them in next fall. But for this section here, let's focus in on these. So let's go ahead and start finding some limits, and we'll employ the factor and cancel technique. We'll use some trig functions. We'll remember what a conjugate is and how to use that. Also how we can combine rational expressions using common denominators, and then also expanding power. So all these different little tricks for different ways of manipulating the function algebraically so that we can find the limit. Let's start with a real simple one here. Example 1, it says find the limit as x approaches 3 of x to the negative 2. So again, our first instinct for finding a limit will always be direct substitution. So we would just try direct substitution, where we plug 3 directly in, and we'd get 3 to the negative 2. Well, negative power means move it into the base. So we'd have 1 over 3 squared, which is 1/9. And there's our limit. The limit as x approaches 3 of x to the negative 2 is 1/9. Okay, so if we're lucky, it'll be this simple. For continuous functions, it'll be real easy for us to find the limits by direct substitution. Our first instinct is always to use direct substitution, always. Okay, and so as we go through all these other ones, direct substitution is not going to work most of the time, but we should always be checking direct substitution first. Okay, and so in the next video, we're going to start looking at all the different types of techniques that we can use to find limits when direct substitution does not work.